Okay, hi everyone. My name is Lauren Menting. I work at ProSoft, and I'm pleased to welcome you to today's webinar. Today we'll be discussing key wireless considerations for automated logistics applications. And again, before we start, we encourage you to post questions to the Q&A box during our session, and we'll get to those at the end. Your host today is Brian Allport. He's our Business Development Manager focused on wireless solutions here at ProSoft. Brian, take it away.
Great, thank you, Lauren. Good afternoon, good morning, everyone. First, I'll say I appreciate everyone's time here. I know this is a unique market condition for us. This is a unique market condition for our customers right now. And I think this topic of automated logistics is timely considering the environment we're living in right now. I know we all at ProSoft are working hard to help our customers solve their connectivity and communications challenges. And I know you all in your businesses are working hard to bring value to your customers. So if we cut through all of that noise, what we have left are our customers working hard with the same focus. How do they grow their business? How do they fill the evolving needs of their customers? What's shifting in their market landscape, and how do they better position their business for the future, right? We all know this. So this is where automated logistics comes in. As emphasized by the market condition we're in right now, logistics or fulfillment isn't just a function or a department of a business, it's an opportunity for a strategic differentiator. These are no longer cost centers. When implemented correctly, there's a real and tangible value to the business. There's an ROI. This is an important topic. It's a growing market, and this is what we're going to talk about today. So with that said, I'm Brian Allport with ProSoft Technology. I have a few slides here, about 30 minutes worth. It'll be quick. We'll give you a quick introduction into who we are as ProSoft, how we can help with some communications challenges in an automated logistics environment, and some key considerations when deploying a wireless communications network with different types of mobile robotics like those that we would typically see in an automated logistics environment. So let's jump into it. So we as ProSoft are a California-based company. I think a lot of you know that. We're best known for our in-chassis solutions. We have a long history of focusing on connecting different types of electronics to a Rockwell controller. From that experience and those automation applications, we're able to leverage what we learned about these different types of critical applications to expand our connectivity portfolio with new technologies. And it's these new technologies that we use in this automated logistics space. So this started with a portfolio of industrial wireless products. And then more recently, we grew this to include a portfolio of cloud connectivity products. We have a really nice future-focused solution here that we call ProSoft Connect that enables customers to remotely and securely access their equipment for things like troubleshooting or even commissioning. All really cool stuff. We'll talk about that a little more in these next few slides. So we're a global business. We have offices and employees all over the world, which enables us to stay connected with our customers and provide global ProSoft level support and service across all of the industrial verticals that we focus on. We really focus on any industry that leverages industrial control technology. But just to name a few, we focus on process manufacturing, we focus on energy, we focus on infrastructure, discrete manufacturing, and of course, we focus on automated logistics. So that's who we are. This is the lens that I'm coming from. Let's jump into it. So what is automated logistics and what kinds of trends are driving the innovation in this market? I think we could say automated logistics essentially refers to automated material handling in warehouses, robots moving stuff, and it's happening more and more, and it's enabled by several technologies, some of which we at ProSoft focus on. So in this large and growing market, there's a lot of trends that are pushing automation forward to better enable these applications. E-commerce is one of the largest trends affecting this industry. I've seen several reports suggesting it's remaking the entire industry through something called the Amazon effect. Customers, no matter if they're an industrial or commercial business or an individual consumer, now have different expectations on fulfillment time. So now businesses need to consider with greater weight when their customer expects fulfillment and how to make sure they're not slower than the competition in satisfying that need. There's several different ways to improve fulfillment time. Historically, this has been through an intelligently laid out network of distribution centers to gain access to the local customer base. Now, for even more improved fulfillment time, we're starting to see micro fulfillment centers. So the result is that our customers are growing their distribution networks, and their customers are starting to purchase things through different channels, direct, through a distributor, through a store, or online. And the only way to satisfy these omni-channel fulfillment needs is through automation, namely through automated robots. So we'll talk a little bit about what these different robot technologies look like a little later, but what we can say now is that all of these technologies need to be networked together for seamless communication, for the control of the distribution center, for the safety of the distribution center, and for the planning systems or the warehouse management system of that distribution center. These applications truly follow the trends associated with the connected enterprise. So let's jump into the meat here of what that automation network may look like in a distribution center. So the typical network segmentation of an application in a connected warehouse may look like this. You may have your enterprise network typically filled with IT level components from a commercial networking vendor. This is where your ERP system is located and where your warehouse management system is located. This is where all of the data gets pulled from the main control network to feed these enterprise systems. Then you have the main control network, and that's where the industrial components come into play. Here you have your main PLC talking Ethernet IP, Profinet, or some other industrial protocol, and it's responsible for coordinating the automation on the edge of the network, and that automation is at the bottom of the screen. This automation at the edge of the network could be split into 3 segments, just like what you see here. First, you have your automation infrastructure. Think of this as the same area where the physical shelves are located that your robotic system or automation is moving around and picking from. The automation infrastructure consists of a network with automation equipment like PLCs, sensors, safety relays, cameras, other I/O, and all of this is connected with a wired Ethernet system to the main control network. Then we have the robotic carrier that's moving through this infrastructure. This robot hosts several pieces of automation technology on board. It may have its own PLC for control, a drive for propulsion, sensors, I/O, all for different pieces of control and diagnostic input. And as you can imagine, it's critical in these applications that this robotic carrier communicate with the automation infrastructure so it knows where to go, what to pick, and where to take it. We can call all that control information, and it's critical that the control information is sent to the carrier quickly and reliably, and this is accomplished through a wireless link to establish and maintain a connection to the network. And that's what you can see here in the middle of the screen with the dotted line. That's where ProSoft comes into play, radio to radio. After the robotic carrier picks the part, it may need to be delivered to the operator station. This station is basically the packing station with all of the automation technology to give the operator instructions on what to do and to provide feedback back into the control network for the ERP or for the warehouse management system. So connectivity and coordination through this whole application is critical, and uptime is important for an efficient application. But as soon as you involve people in close proximity to these robotic carriers, safety is also important. Safety is satisfied through local proximity sensors on the robotic carriers. It's also satisfied through safety communications between the PLC on the robotic carrier and the PLC in the automation infrastructure. And this safety communication could be SIP safety, it could be ProfiSafe. What's true between them both is it requires a constant link between the automation and the infrastructure. The rest of this presentation highlights how ProSoft can help with this wireless link to maintain uptime, to maintain reliability, and to maintain safety in these applications. So with that said, what we're really focusing on is this critical connection between the automation infrastructure and the robotic carrier. So we already talked a little bit just now through some of the requirements that create the need for this wireless connection. There's automation controlled data being sent through the link. There's diagnostic data being sent through that wireless link. There's safety data being sent through the wireless link. So all things considered, a reliable connection here is critical for application uptime. And that's why you need a designated and purpose-built wireless network for that automation. It's important that this wireless link is separate from the enterprise level network and from the plant level network. Those are IT level networks where enterprise level applications live and where the network core is. we're talking about the control level network and the device level network, and this is where the OT level network is, consisting of industrial components to maintain uptime in mission critical applications. So beyond the actual network segmentation, there are several things that make an industrial networking component different than a commercial networking component. Industrial components are more reliable and offer a more robust design, making it more flexible for real applications. Industrial components like those from ProSoft are designed to withstand the shock and vibration often seen in an industrial application, like if it were installed on a mobile robot. Using a product that's designed to withstand the physical environment of an industrial application helps ensure uptime and high levels of productivity, and all that's a requirement in applications like this. These industrial components are also engineered for the precision timing of data, which is required in industrial control systems. So this is critical in applications where safety data may be used. You need a device that's engineered to facilitate real-time industrial communications, and that's what we engineer here at ProSoft. And lastly, these industrial products aren't just designed for use with control systems. They're just designed to be integrated into the control system. We offer add-on instructions for use in Rockwell systems, as well as several other features to ensure successful integration into a mission-critical automation application. So now that we're aligned with where the automated logistics industry is headed, what the typical network may look like, and why using ultra-reliable industrial components is required for a successful network long-term, let's look at what ProSoft has to offer to help with that critical wireless link between the mobile automation and the automation infrastructure. So this is where our RLX2 wireless Ethernet radios come into play. I have a few highlights here of what this product is and what stands out about it. So we leverage 802.11n technology, which enables a standard wireless Ethernet connection in both the 2.4 and the 5 gigahertz bands. And with this technology, we spent a lot of time developing a proprietary algorithm that enables something that we call ultra-fast roaming. So roaming is when a client device or something that you have connected to a wireless network, like a robotic carrier, moves out of range of one access point in the infrastructure and into the range of a new access point in the infrastructure. There's a hop over time for the mobile carrier to roam from access point to access point, and in industrial automation systems, it's critical for this roam to happen as fast as possible to avoid a communications loss. A commercial wireless system may take about half a second or more to facilitate that roam. Our solution takes 10 milliseconds or less. We all also know that in industrial applications, it's critical to be able to deploy or troubleshoot electronics as fast and as easy as possible. And we have a really nice and easy to use user interface that doesn't require any IT experience at all to configure these devices. And we have a really nice benefit of offering access point and client capabilities within a single part number. So it's easy to manage spare parts in these critical applications. And lastly, I'll note that all of our radios have wide temperature ratings, and we have a portfolio of IP67 radios. So they're really purpose built for these automated logistics applications. So since our RLX2 radios leverage 802.11 technology, they could be used in any application that any other wireless Ethernet radio could be used in. In a stationary application, like what you can see here on the left, it could be used as the wireless infrastructure, connecting your fixed automation equipment through the application and enabling a mobile worker with a local Wi-Fi connection. But it's this application on the right that we're going to focus on, a mobile or roaming application. So I'll blow it up here. And you can see here that we have a control room where you have your main controller on the left side of the screen. This is the automation infrastructure. Connected to this main controller is the network, which includes access points, which enables the connectivity to the robotic carrier. You can see the robotic carrier in the red box on the right side of the screen. So we have RLX2 radios as access points in the infrastructure and RLX2 radios as bridges on the mobile robotic carrier. As this mobile robotic carrier moves throughout the logistics facility, you can see it moves out of range of one access point and into the range of the next access point. This is where the roam happens that we talked about, and this roam needs to happen as fast as possible to maintain these communications of the onboard controller and the controller and the automation infrastructure. And this is why our industry-leading ultra-fast roaming is so critical in these automated logistics applications. It's the key to having a reliable application for sure. So let's look here at some different types of mobile automation that our wireless radios have been used on in this automated logistics industry. So you can see here, starting on the left, our technology can be leveraged with auto-guided vehicles or auto-guided cart applications. And they're typically used for goods or material handling throughout the facility. We work with automated storage and retrieval systems, which often consist of a complete turnkey automated logistics solution. They're big systems. And we work with automated guided pallet trucks for material movement and load exchange. Oftentimes, these pallet trucks go both inside and outside of the facility. So an engineered wireless network is really required for complete coverage, and IP67 radios are usually a requirement since they travel through an uncontrolled environment. So we can help with both of those things. And we often work with other types of mobile robots. Increasingly, this technology is improving, and these devices are working towards becoming fully autonomous. As these mobile robots learn to make dynamic decisions in the application, wireless connectivity is required to track the location of the robot, to communicate what material needs to be moved, and to allow the robots to communicate with each other for the best decision-making. So let's take a bird's eye view of what a typical layout may look like and where these technologies may fit in. So here you can see the layout of a logistics facility. The red line shows the path of travel for the automation, and the ProSoft radio logo shows the general layout of the access points in the automation infrastructure to ensure constant connectivity throughout this entire application. Each of the robotic carriers we just talked about has their own use case and therefore could be used in different parts of a logistics application like this. So I overlaid where I think they might fit. As you can see here, the ASRS system may be in this bottom segment. All of the shelves create a dense environment that's challenging for wireless communications. So the layout of the radios in that area is critical, and I'll talk a little bit about how we can help with that. Then you have an AGV or AGV system that could be carrying product from the ASRS system to a packing station. And from the packing station, the auto-guided pallet trucks may take the packages in bulk to and from the loading docks. This is all theoretical, but I put this together with PowerPoint CAD to give us a sense of what a simple distribution center may look like. But with all this in mind, we can talk a little bit about a real-world ASRS application that we worked on. So here we have an example of an ASRS system, and our end user here was a global leader in the food and beverage industry, so this system was huge. The key in this application was to establish and maintain connectivity of the ASRS system through the dense metal shelves, so everything could be integrated into the warehouse management system. That's a typical requirement in this space. So as you can imagine, an application like this with all of the metal shelving was a challenge. Line of sight between radio antennas was difficult, and multi-path distortion was common when using standard antennas. To meet the need of creating that reliable wireless link, we used radiating cable along the shelves of the ASRS system connected to the access points. The radiating cable provided a reliable wireless connection to the RLX2 on each carrier throughout the entire path of travel. The solution provided the reliable wireless connection for the control and for the diagnostics that the customer required. And it was all really enabled by that radiating cable. In addition to that cable, the application benefited from our ultra-fast roaming time as the carriers traveled through the ASRS system and roamed from one access point with radiating cable to the next access point. The customer also benefited from several other features in our radios, including NAT functionality. So each carrier could be configured the same. And all of this resulted in a more reliable application with increased data throughput. So this is a typical application example that we see. So since radiating cable was key to that application, I have two slides here showing a little bit about what it is. Radiating cable is fundamentally a long, flexible antenna. It's also known as leaky coax, and basically consists of an inner conductor, a dielectric layer, a slotted copper outer layer, and radiates through the outer jacket to the mobile carrier antenna. So radiating cable connects to the antenna port of the access point and is installed along the path of travel for the mobile automation. This cable provides up to about 80 meters of reliable wireless connectivity, no matter what the environment looks like. So here you can see that the mobile client has its own wireless Ethernet radio with an antenna installed in the direction of the radiating cable. Then in applications where the mobile automation travels beyond the length of the first segment of radiating cable, we can overlap the end of the radiating cable with a new segment of radiating cable connected to the next access point. You can see that on the bottom right side of the screen, and this is where that wireless roam would happen. This is another way that we can ensure it happens quickly and reliably. So now that we have a sense of the key trends driving the industry, we have an idea of what the network segmentation may look like, where ProSoft's wireless products fit, and some different technologies that we enable to ensure a successful application. Now we can look at some of the key deployment considerations specific to that critical wireless piece. So when we get started and we have the design for the automated logistics application and we know what technologies we're using, it's important to understand the technical requirements of the application. What kind of data rates are required? What is the anticipated distance to the access point? How many carriers will be installed in the application? At ProSoft, we take a partnership approach to critical applications like these. So we offer a pre-proposal questionnaire to help specify the right antennas, the right locations for the radio installation, all up front. After understanding the technical details, we can start to plan and predict the deployment and look at the theoretical coverage and the placement of the radios, similar to what that bird's eye view of the distribution center that we just looked at. Looking at everything we know, are MIMO omnidirectional antennas appropriate or directional antennas preferred? Do we need radiating cable? We at ProSoft can help define all of this with you. Then to finalize the definition of the radio and antenna placement, we can conduct a site survey. This is an in-person survey where we evaluate the radio spectrum to ensure that we choose the right channel free from other networks, ensure that we have line of sight in the application. Line of sight is critical, and this site survey is a pretty important step in these critical applications. That's something that we can support with. And then after everything is specified, we can deploy the assets in the application, working with the integrator or with the OEM. We can also integrate the add-on instructions, the AOI, for our radio into the control system. And this can provide diagnostic data like signal strength to the control system. And that extra connectivity really helps increase the reliability of the application and really enables the connected enterprise for the end user. So in a lot of these applications, we like doing that. And then after everything's installed, we can help validate the application with a post-installation site survey to ensure the installation went as planned, and that there's a strong wireless signal strength, and that everything is good throughout the application. So after all those steps, I can leave you with some tips for optimizing the wireless performance for a high availability network. So first, we need to ensure line of sight between the antennas. We talked about this. An engineered layout of radios can help with this, and in some of the more complex applications, radiating cable can be used to maintain line of sight throughout the application. Then you really need to make sure you choose a channel free from other networks, and this helps ensure that there's no interference during the operation. Both of those combined can help maintain a strong signal strength, and it's important to have a signal strength strong enough for the type of communications required. We need to make sure that we're using the best components for the job and that we aren't introducing too much attenuation with the extension cables that are used based on where the radios are and the antennas. And in the overall network, it's important to manage the communication traffic. To improve performance and maintain the optimal channel utilization rate, it's best to limit the wireless traffic to only send the data that's required. For example, unicast messaging is better for wireless performance than broadcast messaging. It's important that only that data that you need is sent. And a lot of times a managed switch in the infrastructure can help with that. And lastly, some of this stuff can get a little complicated, but you can hire a pro. And the good news is our team at ProSoft has a team of field application engineers that can help with all this. They're a great team, great resource. So through these complex projects, we offer a complete suite of professional services and support. We can really help with anything you need to be successful. On the support side, we can help with project management. We can help train local engineering partners to specify and install our wireless solutions. We can help develop specifications to ensure a successful wireless application. And of course, we offer free phone support. On the professional services side, we can help with the design of the entire system. We can help with engineering drawing reviews. We can help with site surveys, installation support, physical inspections, on-site testing, firmware updates, and we can help with troubleshooting. And it's important to us that we take this partnership approach in these large and critical applications to help ensure a high level of uptime. So we're always here to help with these things. So with that in mind, just as we are here to provide a high level of service and a high level of support for our customers to ensure their success, a lot of the major OEMs in this space need to do the same. These OEMs are working hard engineering and specifying everything from the physical shelves to the robotic carriers to the warehouse management system. And if anything goes wrong with the automation in the system, everything's at risk. So these OEMs would really benefit from being able to service their equipment at their customers' request from anywhere in the world in real time. And our secure remote access solution is a great way to enable this. With ProSoft's ASRS, secure remote access, the OEM would install a gateway anywhere they would want remote connectivity in the future. At their customer's request, the OEM will go into ProSoft Connect on their web browser. ProSoft Connect's our cloud-based platform, and request access to that gateway. After the end user dynamically authorizes the access through the auto-generated email from ProSoft Connect, the OEM can access their equipment just as if they're plugged in locally. From here, they can service their system, they can troubleshoot any issues, and they can even install new firmware, adding new product enhancements. Overall, this SRA solution is really easy to use. It can work over cellular with Verizon or AT&T, and it can be it could be hardwired into the internet. There's no software to download or maintain. All you need is a web browser, and it establishes an incredibly secure encrypted connection that gives the end user complete control into who has access, when they have access, and what they have access to. It's a really good solution for any OEM looking to provide world-class support to their end customer, especially in this market. So in summary, you can see here our purpose-built wireless products engineered for the automated logistics industry. Our RLX2 wireless LAN radios are ideal for connecting automated carriers to the automation infrastructure, and our secure remote access solution is ideal for enabling remote service and support for these OEMs. This is all really good stuff. Thank you all for your time. I hope you found some of this content valuable. We have a few other pieces of valuable information that we'll email out to everyone who registered later today. We have a wireless tips and tricks sheet, a SIP safety over wireless application guide, a radiating cable user guide, and a few other things. And with all that in mind, how can we help?
So great presentation, Brian. We did get a couple questions in. And before I get to that, just a reminder to everybody who's on the line that if you do have a question now that you've seen the presentation, feel free to put that in the Q&A box and we'll answer it. So the ones we did receive, one was asking if precision time protocol, PTP IEEE 1588, it's commonly used in supporting wireless connections between robotic carriers and control systems. Wondering about the usage there.
So the question is 1588 commonly used for that communication?
Yeah.
I do not believe so. I think There's not too many radios with the hardware clock installed in them to enable 1588.
Okay.
But we can look into that.
Okay, cool. Another question was someone wondering how you handle channels and environments that also have enterprise 802.11 Wi-Fi.
Yeah, this is where that's a great question. This is where our field application team can help. During the site survey, you would analyze which channels are used with any other 802.11 system, whether it's the IT system or a different OT system. And from there, you can identify which channels are available and choose one of those. The first page in our UI for our radio has a nice window that can scan it all for you too, so you don't need someone from ProSoft to do it for you. It's pretty easy to do yourself just by sniffing the spectrum with our product.
Cool. And the last question was asking about if we'll be sending the presentation after the webinar, and we will be sending the slide deck, the recording, and the helpful resources that Brian mentioned to you all after the webinar. So, yeah. And I think that's everything we had today. So thank you, Brian, and thank you everyone for joining us.
Thank you.
Thanks. We'll talk with you all soon. Thank you.